The exception in section 695.6 applies only to the normal source wiring of a standby generator system. The generator feeder and any taps ahead of the service disconnecting means must still be installed as service conductors. This is because the generator feeder and taps are still part of the service entrance and must meet the same requirements as the normal source wiring. Section 695.4.1 requires protective devices to carry locked rotor current indefinitely. This requirement applies to all protective devices, including those protecting the normal source wiring and the generator feeder. Section 695.6. The exception 2 allows 430.52 protection methods to be followed for generator feeders. However, this exception does not apply to protective devices protecting the normal source wiring. Let's consider a specific situation. The normal wiring to the fire pump is not required to be installed as service conductors according to section 695.6. Exception. However, the generator feeder and the tap ahead of the service disconnecting means must be installed as service conductors. The wiring for the generator and the normal source should be routed along different paths and should be protected from physical damage. The control wiring for the generator should be in concrete or mineral insulated cable. If an existing installation does not meet the requirements of the National Electrical Code, then the normal wiring and the generator feeder should be installed in 2 inches of concrete or should be routed along different paths. The control wiring should be in concrete or mineral insulated cable. The fire pump controller should be listed for use with the specific generator and transfer switch. The generator should be sized to provide the locked rotor current of the fire pump and the controller. The generator should be tested in accordance with NFPA 110, standard for emergency and standby power systems. The test should include a load test to verify that the generator can provide the required locked rotor current. Let's delve deeper into the specifics of these requirements. When examining section 695.6, it's crucial to understand its limitations. This exception is not a blanket waiver for all wiring related to a generator system, it specifically addresses the normal source wiring. The rationale behind this is that the generator feeder and any taps preceding the service disconnecting means are considered integral to the service entrance. Consequently, they must adhere to the same stringent standards as the primary service wiring. This ensures a consistent level of safety and reliability throughout the entire electrical system, particularly for critical loads like fire pumps. Regarding section 695.4.1, the mandate for protective devices to withstand locked rotor current indefinitely is paramount for fire pump operation. This requirement is not selective, it encompasses all protective devices, irrespective of whether they safeguard the normal source wiring or the generator feeder. The intent is to prevent nuisance tripping during the fire pump startup, which demands a substantial inrush of current. If protective devices were to trip prematurely, it could compromise the fire pump's ability to operate when needed most, posing a significant safety risk. Understanding the nuances of section 695.6. The exception 2 is equally important. While this exception permits the application of section 430.52 protection methods for generator feeders, it's crucial to recognize its boundaries. This allowance is not applicable to protective devices that safeguard the normal source wiring. The distinction arises from the fact that generator feeders often have different characteristics and operational profiles compared to the normal source. Section 430.52 provides a more tailored approach to protecting motor circuits, accounting for factors such as motor type and starting method. However, the normal source wiring is subject to stricter requirements to ensure its robustness and reliability as the primary power source. To reiterate with an example, in a high-rise building with a fire pump, the normal wiring to the fire pump is not mandated to be installed as service conductors due to the exception in section 695.6. Conversely, the generator feeder and the tap situated ahead of the service disconnecting means are unequivocally required to be installed as service conductors. Moreover, the physical separation and protection of wiring are critical considerations. The wiring for both the generator and the normal source should be strategically routed along distinct pathways to minimize the risk of simultaneous failure. Furthermore, these wiring pathways should be adequately protected from physical damage to maintain their integrity during adverse events. In addition to physical separation and protection, the control wiring for the generator warrants special attention. This wiring should be encased in concrete or utilize mineral insulated cable to provide enhanced protection against fire and mechanical damage. These measures are essential for ensuring the reliable operation of the generator control system, which is vital for the fire pump's functionality. When assessing existing installations, it's imperative to verify compliance with the National Electrical Code. If the normal wiring and the generator feeder are not installed in 2 inches of concrete or routed along separate paths, corrective actions are necessary. Similarly, if the control wiring lacks adequate protection in the form of concrete encasement or mineral insulated cable, it must be upgraded to meet code requirements. Furthermore, the fire pump controller should be specifically listed for compatibility with the generator and transfer switch being used. This listing ensures that the controller can effectively manage the generator's output and seamlessly transition between the normal and emergency power sources. Additionally, the generator should be properly sized to accommodate the locked rotor current demands of both the fire pump and the controller. This sizing calculation must account for the inrush current experienced during motor startup to prevent overloading the generator. Finally, the generator's performance should be rigorously tested in accordance with NFPA 110, standard for emergency and standby power systems. This testing should include a load test to validate that the generator can reliably deliver the required locked rotor current under real-world conditions. In summary, the National Electrical Code provides specific guidelines for fire pump wiring and generator installations. These guidelines address service conductor requirements, locked rotor current protection, wiring methods, and testing procedures. Adhering to these requirements is essential for ensuring the safety and reliability of fire pump systems, which are critical for protecting lives and property. Understanding the nuances of these code sections is vital for electrical engineers, contractors, and inspectors involved in the design, installation, and maintenance of fire protection systems. It is also important to remember the testing of the generators, and this should be done in accordance with NFPA 110. Let's recap some of the key points. Firstly, Section 695.6. A's exception applies only to the normal source wiring of the standby generator system. Secondly, generator feeders and taps ahead of service disconnecting means must still be installed as service conductors. Thirdly, this is because the generator feeder and taps are still part of the service entrance. Fourthly, Section 695.41 requires protective devices to carry locked rotor current indefinitely. Fifthly, this requirement applies to all protective devices. Sixthly, Section 695.6. G exception 2 allows 430.52 protection methods for generator feeders. Seventhly, this exception does not apply to protective devices protecting the normal source wiring. Eighthly, wiring for the generator and normal source should be routed along different paths. Ninthly, control wiring for the generator should be in concrete or mineral insulated cable. And 10th, the generator should be tested per NFPA 110. Now let's elaborate on the significance of adhering to NFPA 110 for generator testing. NFPA 110 outlines comprehensive testing protocols to ensure that emergency and standby power systems, including generators used for fire pumps, can perform reliably during power outages. These tests cover various aspects of generator performance, including startup, load carrying capacity, voltage regulation, and frequency stability. One critical test specified in NFPA 110 is the load test, which involves subjecting the generator to a range of load conditions, including the locked rotor current of the fire pump. This test verifies that the generator can not only supply the required inrush current but also sustain the load for an extended period without experiencing voltage drops or overheating. In addition to the load test, NFPA 110 also mandates periodic maintenance and inspection of generators to ensure their continued reliability. These maintenance activities include checking fluid levels, inspecting wiring connections, testing batteries, and verifying the proper operation of control systems. By adhering to the NFPA 110 standard, building owners and facility managers can have confidence that their emergency power systems will function as intended when needed most. It is also important to consider the coordination of the different protection devices in the system. Selective coordination is a design practice used in electrical power distribution systems to improve the system's reliability and safety. In a selectively coordinated system, only the protective device closest to a fault should open, while other devices upstream remain closed, thus isolating the fault and maintaining power to the rest of the system. Fire pump systems are often required to be selectively coordinated to ensure the fire pump remains operational during a fire event. The normal and generator sources that supply the fire pump are required to have overcurrent protection devices that are selectively coordinated so that only the overcurrent protected device nearest the fault opens and the fire pump continues to operate. This typically requires a time current study that will document the time current curves of each of the devices to ensure selective coordination. There are also several options for achieving selective coordination, including using fuses, circuit breakers with short time delay, and zone-selective interlock circuit breakers. Fuses can provide fast clearing times and are inherently current limiting. Circuit breakers with short time delay allow a brief delay in tripping, providing coordination with downstream devices while still offering overcurrent protection. Zone-selective interlock circuit breakers communicate with each other, ensuring that only the breaker closest to the fault trips. Now let's discuss the importance of physical protection of the electrical conductors. The National Electrical Code (NEC) requires that electrical conductors be protected from physical damage. There are several methods of providing this protection, including rigid metal conduit (RMC), intermediate metal conduit (IMC), electrical metallic tubing (EMT), and mineral insulated MI cable. Rigid metal conduit (RMC) is a heavy-walled threaded conduit that provides excellent physical protection. Intermediate metal conduit (IMC) is a thinner-walled threaded conduit that offers good physical protection at a lower cost than RMC. Electrical metallic tubing (EMT) is a thin-walled and threaded conduit that is commonly used for branch circuit wiring. Mineral insulated MI cable consists of copper conductors insulated with magnesium oxide, providing excellent resistance to heat and physical damage. Another area to consider is the grounding of the electrical system. Proper grounding is essential for electrical safety and the reliable operation of electrical equipment. The National Electrical Code (NEC) provides detailed requirements for grounding electrical systems. The grounding system includes the grounding electrode conductor, the equipment grounding conductor, and the bonding jumpers. The grounding electrode conductor connects the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The equipment grounding conductor provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device. Bonding jumpers are used to connect metallic parts of the electrical system together, ensuring that they are all at the same potential. The grounding system must be properly sized and installed to provide effective protection against electrical shock and to prevent equipment damage. We should also briefly touch on the emergency power systems and their importance in maintaining critical operations during power outages. Emergency power systems are designed to provide a reliable source of electricity when the normal power supply is interrupted. These systems are used in a variety of applications, including hospitals, data centers, and fire pump installations. Emergency power systems typically consist of a generator, a transfer switch, and a distribution system. The generator provides the backup power source. The transfer switch automatically switches between the normal and emergency power sources, and the distribution system delivers power to the critical loads. The transfer switch should be an automatic transfer switch. An automatic transfer switch (ATS) is a device that automatically switches a load between two power sources. In an emergency power system, the ATS is used to switch the load between the normal power source and the generator. When the normal power source fails, the ATS automatically starts the generator and switches the load to the generator. When the normal power source is restored, the ATS automatically switches the load back to the normal power source and shuts down the generator. The ATS must be reliable and capable of switching the load quickly to minimize downtime. Remember to perform regular maintenance on the fire pump system. Regular maintenance is essential for ensuring the reliable operation of fire pump systems. Fire pump systems should be inspected and tested on a regular basis to identify and correct any potential problems. Maintenance activities include inspecting the pump, motor, and controller, checking fluid levels, lubricating moving parts, and testing the system under load. Regular maintenance can help to prevent equipment failures and ensure that the fire pump system is ready to operate when needed. Lastly, remember that codes and standards are continuously updated and revised. Therefore, staying updated is crucial to stay compliant.